You have a question? Oh, just stretching. Okay, so Lewis structures, you're only going to do these for molecules, which means your bonds there will be covalent. So we're sharing electrons. This is not something that you're going to do on ionic bonds. That's different. It's going to be a visual representation of the atoms and where those electrons are shared between the atoms. And so you have to be able to do these before we determine shapes. And so just in your head, like if you think about a molecule, it's probably not flat, like two-dimensional. It has a shape. And tomorrow we're going to build the shapes with like toothpicks and candy and marshmallows. It's going to be super fun, and the world will all make sense, and it'll be great. But you can't do that if you don't know how to do this. And so let's start. This is where I'm going to leave the PowerPoint, and I'm going to go over here, and I'm going to tell that goodbye. So this is what you do. You have your compound. Make sure it's covalent, right? And so it is. But the first thing you're going to do is you're going to count your valence electrons. And so the way I'm going to do that is phosphorus is in group 15. And so it's going to have 5 valence electrons. Remember, that's the ones place. And then chlorine, I have 3 chlorines. So I'm going to have 3... there we go. Chlorines in group 17, so I'm going to have 3 times 7, which is 21. So 5 plus 21 is 26. So when you get done, your picture needs to have 26 electrons in it. Okay? Now, step 2 is you're going to draw a skeleton. And make sure that you have enough ribs. Just kidding. 0 people thought that was funny. You're going to draw a skeleton, which is just a single bond, single bonds to central, to the central atom. And remember that central atom is going to be that least electronegative. And in this case, I mean, phosphorus is less electronegative than chlorine, but when you have 3 of something and 1 of something, that 1 of something's probably in the middle. So I'm going to draw phosphorus, and I'm going to draw a single bond to all 3 of the chlorines. All right? Now, that's 6 electrons, 2, 4, 6. And I need to have 26 in this picture. So the next step is I'm going to fulfill the octet. And these are called terminal atoms. The ones on the edge, those are terminal atoms. This is called the central atom. I'm going to fulfill the octet. That just means I'm about to draw 6 on these. So 6 plus 2 is 8. So fulfill octet for terminal. Now, if this was pH3, which I don't even know what's the thing, but let's say it was, I would not draw 6 dots on every hydrogen, because hydrogen doesn't need 8 electrons to fulfill its octet. Hydrogen only needs 2, and so if this was an H right here, it would be full. That hydrogen would be full. So anyway, I'm going to fulfill the octet by placing 6 electrons on each of these. And if I look, 2, 4, 6, 8, 2, 4, 6, 8, 2, 4, 6, 8, that's 24. How many electrons do I need to have in my picture? Yeah, and so the extra ones, do y'all have this? I have to kind of give myself some space. The extras are going to go on the central atom. So here's step 4. Place extra electrons on the central atom. Now, step 5, unwritten. Check yourself before you wreck yourself. And so here's how you check. Everybody should have 8. That's 8. That's 8. That's 8. And then the phosphorus has 2, 4, 6, 8. Now everybody's happy. That's why they bonded in the first place, okay? So they could all fulfill their octet. Is that so bad? Not really that bad, right? Alright, let's do some more. And they're going to throw dots and stuff up here. They're like, oh, blah, blah, hydrogen, blah, blah, blah. Drawing dots. I already did this. Alright, so let's do CO2. Same steps apply. And, you know, if I'm doing this, it doesn't matter if I'm doing this on my own paper for my, because I do homework, but like if I give it out, I do it too. Especially for AP. But I do this, like I do these steps. They're not magic and you just have to know the answer. You have to do the steps. So CO2, I'm going to count my valence electrons. So carbon has 4 and oxygen has 6 times 2 because there's 2 of them. Each one has 6. And so it's 12. And so total, you know, 4 plus 12 is 16. So my picture's going to have 16 electrons. I'm going to place a skeleton structure around my carbon. That's step 2. Step 3 is to fulfill the octet. So, now, any extra ones go around that central atom. How many electrons I've shown? Well, let's see. 2, 4, 6, 8, 10, 12, 14, 16. Do I have any extras? No, I don't have any extras. So I cannot, this is the most common error, I can't just be like, do-do-do, la-la-la, I'm done. That ain't a thing. You can't do that. You don't have 20 to work with. You have 16 to work with. So what you do in this case, this is like step 6, right? So all those first 5 steps, and then sometimes, whoops, there's an invisible step 6. Written with the eraser. So sometimes, if you need to, you will move lone pairs to form bonds with the central atom. So, let me show you what that looks like. I know some of y'all are writing it down. I don't want to do it while you're not looking. So sometimes in a case like this, that carbon only has 4 electrons. That ain't okay. It all has to, they all have to have 8. So what I'm going to do, watch this. This lone pair, do you remember yesterday 2 dots was a line? That's what a line, or like a mean froggy face. That's that one guy that's like, rah, rah, rah. You know the guy? He says sometimes. So anyway, watch. This is a lone pair. I'm going to move it here like that. Now, carbon only has 6 electrons. This oxygen has 8. That oxygen has 8. This has 6. Now, I could make a triple bond right on this side. But a triple bond, when you go to do that, there's some like ninja level stuff you ain't going to learn in this class called formal charge. You don't want to do that, okay? So what you want to do, I mean, doesn't it just make more sense, too, to take this other lone pair on this other side and kind of make it symmetrical? If you make it symmetrical, that'll sometimes take care of your problems. So I'm moving this lone pair to right here. Now let's see what we got. 2, 4, 6, 8. 2, 4, 6, 8. That's 16. Everybody has 8. 2, 4, 6, 8 on this carbon. And this oxygen has 8. So everybody's happy. Isn't that nice? You good? Okay. Ma'am? No. The other way, in this class, if you did the other way, I'll probably give you credit, but it's not right. And I can go into that, but I'm not helping right now. So, I mean, that just looks better too, right? Okay. So there's your carbon dioxide, and then there, you know, the carbon is the least electronegative. It goes in the middle. And then there's their single bonds. It doesn't work. They move on double bonds. On this, this is hydrocyanic acid. Let's draw this hydrocyanic acid. And actually, I think I'll do one more for you. You're going to get lots of practice on your whiteboard. So just do one more. Actually, I'm going to do 2 more. Carbon is still the least electronegative if I'm doing HCN. I'm going to add up my valence electrons. Watch how, this is how, if I'm doing my own paper, this is how I really do it. To add up my valence electrons, I just do this. 1, 4, 5, and then I add them. That's how I do it on my paper. But I was trying to show you. That's a lot faster and don't take up much space, right? So, Carbon still goes in the middle because it's the least electronegative. Hydrogen has to be terminal. And there's your nitrogen. The next step is I'm going to fill the octet on those terminal atoms. I'm not going to put dots around hydrogen. Don't do it. It's not worth it. It's already happy. Now I'm going to check my central atom. It doesn't have a full octet. So what I'm going to have to do now is I'm going to start moving those lone pairs. So I'll have 2, 4, 6, 8, 10 electrons like I'm supposed to, but I don't have any extra for this carbon. So if I had, if this was 14, then sure, I'll go dot, 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 dot and call it a day. But I only have 10, so I have 10 showing. So I'm going to move this here to there. So now I'm going to check my carbon. Nitrogen's good, hydrogen's good, carbon's still short. I can't do anything with this hydrogen. It doesn't have anything to give me. I only have 2 electrons over here. So I will have to make a triple bond right there. And I'm going to do that by moving these 2. Now, everything's fine there. So sometimes you do have to make a triple bond, but you had no other choice here. So there's an example of that. The last part of your PowerPoint, it goes into pi-atomic ions. And so iodate here, let's look at the periodic table. Iodine is actually farther to the right than oxygen. But the 3 most electronegative elements on the periodic table are nitrogen, oxygen, and fluorine. Like, I just know that. It's the thing. So iodine is in the middle. So for this pi-atomic ion, there's a special thing you have to do for pi-atomic ions. Hello. Alright, so IO3. Check this part out right now, okay? Let's count up our valence electrons. 7. Then I have 6 times 3. What do you think I'm going to do with this negative sign? Is that an extra electron or did I lose an electron? It's an extra one. Now, if this was a plus sign, sure, I lost an electron. But this is a negative sign. So this right here means I have 1 more. So I have 7 plus 18 plus 1. So I'm showing my work for everybody. So I have 26. So my picture is going to need to have 26 valence electrons. Iodine's going to go in the middle. And I have 3 oxygens. And I'm going to start fulfilling my octet for those outside oxygens. That's 24. I mean, once you get good at this, if you've drawn a stick to each terminal atom and then put 6 dots on it, that's 8. 8, 8, 8 is 24. So I have 2 extra. Yay! I put the 2 extra on the central atom. And now everybody, I'm not making it better. Now everybody has a full octet. Yes, sir.
So how do you know when it's okay to put the 2 dots on the central atom?
So if you have some left over. See, we had 26 to work with. And so when I did, like if I go back in time, that's 24. And so I have 2 left over. Now, if this had said, when I add all this up, if I had gotten 22 or 24 or whatever, if I had gotten 24, for example, this would be all I had to work with. And so that's where I'd have to move some to give iodine enough. But see, since I have 2 extra, because this is 8, 16, 24, then I can put the 2 extra on the central. Now, this is the trick for polyatomic ions. You look, watch. This is the only thing you missed. You have to put them in square brackets. Then you have to put their charge up here.
So, wait, so I drew like that part, right? Like,
you drew everything right, but you would have needed to draw the brackets and then a 2- for carbonate. So, good. So that's how to do these. What I want y'all to do now is you're going to go back a couple pages in your packet, and the rest of those polyatomic ions and compounds, there's 4 pages of them. When I copied this off, I should have noticed like how many crazy steps they had. I didn't realize it. There's the first one is CH2O. Do you see that? Okay. So what I want y'all to do is I want you to get a big whiteboard, which is there on each side of the table now. And I want you to work with a partner. I have a couple people out, so if you like want to work with Chrissy, that'd be fine. But anyway, do these, and do you see how many crazy steps they have here?
yeah.
That is not necessary. You don't need to subtract and from them. Do what I showed you on the board, and then pick a box and draw the right answer. Okay? If you want to, you can start there. You can start. There's 4 pages. You can start with any one you feel comfortable. But this is what you're doing right now for practice. When I check it, you can write it on the packet. You'll want to use the whiteboards today because you're going to be erasing electrons and moving around, and it'll be nice. You want to use the bug paper.